In this second episode of the multi-trial series, we're going to continue off from the first episode where we went over how to modify the loops covered in Series 1, the single trial series, so that they can loop through all the trials we've recorded across all of our sessions. Now what we're going to do is create some code here to prompt whether or not we want to save the real documents or the real figures that we're going to use later on to monitor performance output, and we might get to actually plotting those graphs. So we're here where we left off at the end of number 1. We can close that variable out of the workspace, but all the variables are in here. Again, if we pick a variable that we had, we'll have all the variable outputs for all the trials that we have here. Again, they're not organized by session yet. And we went through and inspected the curves and determined that we wanted to continue. So now what we're going to do is create a new section. And this section is going to be a user selection to save the workspace, which is all the variables and the data over here. So we'll save the workspace and graphs. We're going to specify that they're going to save to a specific location, and that's going to be the player's individual folder. Okay, so this assumes that the data that you have recorded for every specific athlete is in their own folder. Right? So athlete A has a folder, athlete B has a folder, and all the data that you've recorded are saved in that athlete's folder. And all of the outputs that we're going to put here will also get saved into that athlete's folder. Now, the data I've been working with are from a folder that's called pilot, because we're working with pilot data, so it's not really an athlete's folder, but the process is still the same. So let's start with a clearing of the command window. Okay, and this is going to be very similar to what we've done up here with a question dialog. We're going to add another question dialog. Okay, so I'm going to go ahead and do an answer. We can override the old one because we're done with that. We don't need so many variables in the workspace. So we'll do quest DLG one more time. And we're going to ask, would you like to save the workspace and forthcoming graphs? Okay, and again, we can do the 3 dots to send the script to the next line. Now, the reason we're going to put this save prompt now, right, it says forthcoming graphs, is because most of the time, after you might see me do it, I do it all the time, is after a graph pops up and we look at the graph, the first instinct is to close the graph. Now, if we close the graph, it won't remain open to actually save. So I want to determine whether or not I want to save it before I actually close it. And so that's probably just my personal way of correcting my own kind of habits. But I think it's a good one we can have here because we know we're going to create some graphs. We know whether or not we're going to want to save them. We may be looking at an athlete's data again, right, for a second time. And we may not need the graphs to be saved. So let's go with save option. So again, this is very similar to what we've done up at the top. Okay, again, how I organize the lines. You know, you don't need the 3 dots there. You could make this all one big line. We're going to have save. We're going to have the 2 nodes. Okay, and that line now gets ended. Okay, we're going to have handle the response. So that's what this is going to do. We're going to use the switch again. We're going to switch the answer. The case here being save. And if we do hit save, or that option, we're going to create a new save selection. Same stuff we did in the previous video. Equals 1. Case on this side, if we did no. Save selection would equal 0. We end that. Now is going to be where it's going to change. This is dependent on whether or not we do actually save this. So we're going to type an if statement. If save selection equals 1, remember that's if we selected to save. Now we're going to specify a file name and a path to save that document. Okay, now good thing for us is we've already got file names. We've already got pathways, and it's going to save to where we're working in. Okay, so let's go ahead and just open a bracket and go file name, comma, path name. Okay, we're creating those two variable names. Because we've already, so I said, we're working in a certain file and path already, so that was to select the athlete's data. And so that's what we're going to specify. So this is going to be UIPUT file, UIPut file. We're going to specify any type of thing that we put in front of here. So we're going to specify the actual name when it gets to that part. It's going to pop up a dialog box and we're going to type the name in, and that's what that asterisk or that wildcard character specifies. And it will be a .mat file. Okay, and then the title of that box is going to be save file as. We'll end that in the quote, close the line, and this is where we select folder and name the file. Okay, now otherwise we're going to type else. So if any other thing is there, so if save selection is anything but one, file name is going to equal nan. Remember, that means not a number, it's essentially a blank. Path name will also equal nan. Right, and then we'll end that right there. Alright, so if I were to end this bit here with its own section, what I could do is run that section. Oops, I got a problem here. Oh, only one equal sign here. Remember, when we're using the if statements, you need those two equals. So if I were to, let's close this out, I don't like red. And run the section. We'll hit yes for save. We'll then locate the folder. Again, so I discussed previously how mine are organized. I don't have a number of athletes, mine's pilot, so we'll put it in pilot. You'll see here I've already played around with some scripts here for this. This is just counter movement, jump, and landing. So what I can do is just type results CMJ and today's date. What's today? 7/20. And there we go. Okay, now it's specifying that we're going to save. Nothing has saved yet. That's going to be a separate command towards the end. So now the next section we're going to do is to do this same thing, but now for the team results. So I can actually I'll copy this whole section, just paste it. But now here we'll have the team folder. I can call this answer 2 and say, would you like to save the workspace at least to the team folder? So we don't want to save the graphs to the team folder. We only want to save the workspace. We'll leave our save options as they are. We will leave these as they are, but since we've worked with this one just here immediately, and we're going to end up using these save selections later on, we're going to actually change these to answer 2 right here and answer 2 right here, and save selection 2 in all these locations. Okay. We'll then also create a file name too and a path name too. This will all stay the same. And we will update this here and this here. All right. So then we can run this section. So we can hit yes to save. We'll scroll through, same process we've done for the other ones, except for now, I have a team results folder. And here I can call these CMJ. And now I would name it as what athlete, this is pilot, and give it today's date. All right, so you might have an athlete last name, you might have a jersey number, or whatever you organize those as. But we're just calling this pilot, and we know this is the CMJ with the, well, CMJ landing, but yeah, well, let's just actually do that. So CMJ landing. Okay, and then we'll save. Okay, so that is specified now. We've determined whether or not we're actually going to save. Our next bit is going to be to do the meat of this, which is to create the graphs with results. Now I'm going to start with the landing graphs because I want to look at this as jumping first and then landing first. And the way that these are going to produce is that the first graphs in the script are going to pop up. The second graphs in the script, when we get there, will pop up and be on top. So I want to look at jumping, then look at landing. So I need to put the jumping ones as the second set of figures. So here, we're going to specify these as landing. All right, now let's get some space here. Now what we're going to first need to do is make sure we understand what we're going to do with the next bit of line. So to put a note here for what we're going to do, we're going to reshape the variable outputs to organize columns of each session. So the trials for each session, and calculate averages and standard deviations before any plotting. Okay, so that's what the next couple of sessions are going to do. I'm going to do a little bit of a repetitive or a redundancy here, and I'm going to do n, create, so n stands for number equals length my files divided by sessions. Okay, and that's a line that I'm pretty sure we did in the very beginning, but essentially we're just creating the number of trials that we're going to have to make this work for. And so the reshapes, we're going to start with landing height first. And you can start with any variable you want to. We'll go over like 2 of these and then let you kind of explore the other variables that you might do this for. All right, so now we're going to reshape the landing height variables. Right, so if where we have it, landing height, you can see it's 1 row, 15 trials. Now what I want to make this be is 3 columns with 5 trials, because I want to organize these by session 1, 2, and 3. So I'm going to create landing height reshape, and I'm going to use MATLAB's reshape function. Okay, so it's going to actually do all the reshaping, organizational scripting for me within there. And I'm going to reshape landing height, and I'm going to make the number of rows be equal to n, so the number of files that we're going to have per session, and the number of columns be sessions, which we calculated up in the very top. Okay, so if I were to simply run those 2 lines, because I haven't done those yet, and then, oops, that should be sessions. Okay, and if I open up landing height reshape, you'll see I've got 3 columns, that's session 1, 2, and 3, and 5 rows, that's trial number in each session. So now I can start organizing these. And what I'm going to do next, simply for the aesthetics of the plot, I'm going to calculate the mean across 5 trials in each session using a loop. So we've used the for loop before. Now we're going to use the for loop again for this purpose. So we're going to do for. Instead of the counter being I, because that counter was used previously and we want to avoid any confusion, right? The counter I may come up later, and so we don't want to override that by mistake. So I'm going to use J, and we're going to specify that this is going to go from 1 to the size of landing height reshape 2. Now size is similar to when we put length before, but length only did the number of rows. Size provides you with the number of rows and the number of columns. So by doing size of landing, if I can type it correctly, landing height reshape, and then if I do a comma with a 2, it's going to go with the size of the number of columns, right? So if I did just put size, if I just put this line here, that's 3, right? So it's going to go and do this 3 times based on how many sessions I have. Then what I'm going to do here in the loop is calculate my landing height averages. Okay, and then I have to add my counter. Okay, and since there's only going to be 1 row, I don't really necessarily need to specify the rows. So I'm not going to do that here. And then we're going to use MATLAB's mean function, and we'll type landing height reshape. So we're going to calculate the average of landing height reshape. We're going to open that up and say across all of the rows of column J. And we'll close those parentheses where we need to and close that line. Okay, now before we finish this, we're going to do the standard deviations as well. Excuse me. So I'm going to copy this line because it's very similar and just go underneath and change the average to the standard deviations. Okay. And then what I'm going to do is use the STD function, the standard deviation function, and we're going to leave everything else the same. I'm going to hit enter and end that loop. So what this is going to do is calculate 3 averages. So I'll have 1 row of 3 columns of averages and 1 row of 3 columns of standard deviations. Okay, and so now here will be the landing height averages. This is the average across session 1, the average across session 2, and the average across session 3. In the standard deviations, we have the standard deviation across session 1, 2, and 3. Okay, so we've organized those things the way that we want. The next one we're going to use is a function, and I will load this function into the Dropbox where the trials are, so you can download it and put it into your MATLAB path. It's a function that I wrote to calculate Cohens D effect size. So effect size. Let me actually go and actually get it for you rather than search it that way. So I'll go into my MATLAB, we'll go into functions, and we'll pull effect size. So you can see here's the Cohens D calculation where we input a mean value for condition 1, its standard deviation. We also input the mean value for condition 2 with its standard deviation, and then the final 2 numbers are the number of trials or participants depending on if you're doing this on certain data for one person. So for us it'd be the number of trials, but if you're doing an effect size on multiple people, like a group, you would do number of participants. So it's a function, it does this, essentially does this within the function, and gives us an answer that is the Cohens D effect size. Okay, so I'll make that available for this video. But what we're going to do now is do another loop, because we're going to need an effect size for the 3 columns of data that we have in these averages. All right, so the way that we're going to write this is by using another for loop. Okay, so before we do that, let's do a command and let's determine the effect sizes for, and this is the comparison between adjacent test sessions. So essentially, we have 3 sessions now, so we're going to have 2 effect sizes, one for the comparison between trial 1 or session 1 and session 2, and one for the comparison between session 2 and session 3. Okay, so this means we're going to have to do a little bit of different stuff with our loop because we're not going to be able to compute 3 effect sizes. We're only computing 2, right? So the small addition we're going to make here is we're going to do our for loop. J is the counter because it's following the same organizational structure as up here, so we're going to keep that. And it's going to be 1 to the size of landing height reshape 2, so none of that has changed except for now we're going to go -1. So the size of that landing height reshape was 3. We're going to subtract 1 because we know that based on how those things compare, right, 1v2, 2v3, we're going to end up with 1 less effect size than we actually have sessions, right? Because you can't compare session 1 to session 0 when there is no session 0. Okay, so now is where we run the effect size script. So I'm going to go with landing height ES for effect size. I'm going to put J as my counter and equals. Now this effect size script, the way we run it, we'll type in effect size because that's its name. We'll put in the mean and standard deviation for the first comparison. That's landing height averages. We'll add its counter because we want to pull the first one. We'll then insert or type in the standard deviation that corresponds with that. So that would be landing height SDs with the counter J. We will then specify that it's the next one. So to specify that we're doing this for 1 and then 2, the counter is going to change to J plus 1. Okay, but it comes from the same data set. So I can copy this, paste it here, and change this counter J to J plus 1. And I'll do that same thing for the standard deviation, J plus 1. After that, how many trials we're calculating this effect size off of, we can do this based on trials. And then for the second one, it will be the same because we're using the same number of trials. Now remember, trials, that was trials per session, so that's 5. Okay, so that's important because when you do the Cohens D effect size, it takes into consideration the sample size. Okay, so then what we're going to do here is hit enter and then hit end. And this is going to calculate our effect sizes. Now let's see, I did something wrong. No, parentheses. I had my parentheses messed up. Got an error over here. Okay, you can see my typo. I didn't close a parenthesis right here at the end of this. So if I close that parenthesis, clear the command window to get that error out of the way. There it goes. And I have now 2 effect sizes here. So if you know about effect size scales, there's a bunch of different ones out there. You can use the scale presented by Cohen. I like the scale presented by Hopkins. There's also the one that Matt Ray presented if you're looking at these changes based on a resistance training or strength training intervention and you're looking at different kind of samples, so like trained athletes versus intermediate athletes. There's an effect size scale that he put together that might be useful for you. But either way, right here we've got a very trivial effect size and here a small or moderate effect size depending on what you're looking at. All right, now that the effect sizes are calculated, we need to do one more thing for this variable before we can create the plot. And this is to, we're going to create a series of data so that we can plot large effect sizes onto a graph. And essentially we're going to put identifiers onto the graph in between the bars for the different sessions. That's going to denote when there was a large change. Okay, and we'll visualize that once we get to creating the graph. But here's where we're going to do that. So we're going to create data to show large differences. That's the effect size on the plot. Okay, so we're going to use another for loop. And this is going to be a little tricky because we're going to use a for loop and an if statement all together. Okay, so we're going to go for, use our counter j because nothing has changed in terms of how we want to count across. Okay, and we're going to use 1 to the size of landing height, but now we're going to use the effect sizes. And 2 because we want it to go across the columns, not the rows. Then we're going to say if the landing height effect size using the counter, so if that column effect size is greater than or equal to 1.2, so that's me using Hopkins scale. So that's Hopkins scale large effect, okay? This is where you might be, if you're using Cohens scale, you might change this to 0.8. If you're using Matt Ray's scale, I think it's 1.0. But don't quote me on that. So if that that condition is satisfied, a variable called effect size plot, and we'll put our counter. We're going to make this equal to the maximum of the landing height average plus the landing height standard deviation, because this is telling us the height at which we want that little notifier to be graphed at. So if you think about it, we plotted it where we calculated means and standard deviations. So we're going to bar the mean with a standard deviation bar. And so I want this effect size plot identifier to be at that same height as the top end, the upper bound of that standard deviation. So that's why here I'm going to use max landing height averages, so the largest landing height average. I don't need a counter because I want the absolute biggest one, plus the max of the landing height standard deviations. Okay, and I can end that. Else, which means otherwise, so if any other condition is met, ESPlot is going to equal nan, because ESPlot with the counter is going to equal nan, because I want it to essentially put a nan in. So if I try to plot a nan, we've seen this in the first series of figures, if I plot a nan, it's going to be a blank or an empty on the bar. So now what this is going to do, I'm going to go enter and then hit end. That's going to end the if statement. I'll hit enter and hit end, and that will end the for loop. Okay, so if I were to run this line, landing height, yes. Did I type it wrong? Yes, I did not use right here a capital H. Double check, make sure I don't have any other typos in there. Okay, and now here we have, where would it go? ESPlot, E up here. You'll see because both of those effect sizes, if we went down to the landing height ES, both of those were smaller than 1.2. So the ESPlot, in this case, are both going to be nan. Okay. Now's where the magic happens, and now's where we're going to actually create the figure. At least here, we're going to create the first subplot of the figure. And so what we're going to do is copy from our figure we created way up here in the top, this figure state command. You go up here and copy this, pull it and bring it down here, because we're going to use everything the same except for one change. Is now we're going to specify, because these are actually going to be they're going to be retained and saved. So I'm going to make this be h parenthesis 2. Remember, this is the landing, so this is actually going to be the second figure. So I'm calling it 2 because it's going to be behind the other one that pops up jumping, and the jumping one will eventually be h1. Okay, so then we'll put an equals right there also. The only other thing we'll change is right here where it says force curves for inspection. We'll change this to landing results right? And so remember, if I were to run this, right, it pops up the figure window, and up here in the top it says landing results in the top left, right? And that's what we want. Okay. Now what we're going to do is determine the subplot and what plot number it is based on what we're going to graph. So I'm going to create a graph that has 12 figure spaces. Now I've already mapped this out in my head as far as what I want the figure to look like. So you may actually take a piece of paper, this is how I did it, and just draw the figure window, and on the top row, how many figures do you want in that top row? Then in the second row, what do you want? Third row, if you have 3 rows. So the way I'm going to organize this is I'm going to go, top row is going to be my performance variables or my output variables. The next row is going to be my strategy variables, temporal strategy variables, so phase, time, those kinds of things. And then the next row, or rows, depending on what I've got, are going to be my force strategy variables, or what some call driver variables. Okay? So I'm going to open this subplot here, and it's going to be 3 rows, 4 columns, and it's the first figure. Okay. I'm going to do, because we're going to call in a bunch of one variable a bunch of times here for this plot, I'm going to do it. I used to think it's tricky, but it's not very tricky. I'm just going to create a variable here called performance VARS, so performance variables. And I'm going to make that performance variables be equal to landing height averages. Okay, now when we get to the next plot that we're going to create, the next subplot, we're going to have another performance variables, but it will be the new variable averages here. Just so I don't have to keep typing new variables per se. And we're going to have performance standard deviations, and those will be landing height SDs. So when I get to this later on for other variables, I can copy and paste these commands and just change these variable names here. Now what I'm going to do is create a bar graph. So I can simply type in bar. And what I'm going to bar are the performance variables. Okay. What I'm going to do now is put text on there. So rather than forcing the reader to look at the y-axis scale to determine the magnitude of these variables, I'm going to actually put those numbers in. So we're going to use a function called text. We're going to specify the length, so how many text variables we're going to do. So it'll start at 1, and we'll go to the length of performance variables. Okay, we're actually going to use the performance variables here, so we'll type those in again. We're going to convert that numerical data to string data. So num to string. Remember previously in the first video of this series we used string to num. Now we're going backwards the other way. And we're going to round those data points because I don't want them to be super crazy long in terms of how they try to display. So we're going to round the performance variables. Let's put a parenthesis there. Round the performance variables. And we're actually going to transpose them. Okay. And put a comma there and 2. So we're going to round them to 2 decimals. Make sure we close our parentheses out correctly. Now, before we close out the text command, we're going to specify some things. So I want these, so we're going to specify vert, and then we're going to specify top. So it's going to go in the top vertical side of the bar. The horizontal characteristics of that is going to be centered. So I'm going to go here and type horiz, right, H-O-R-I-Z, and specify center. And then I want to make these bold because sometimes if they're not bolded, they're going to be hard to read. So I'm going to type font weight, oops, don't forget my single quote, font weight, and specify bold. Now I can close that command. Oops, actually I have to put a single quote, close that command and suppress. Okay, so now if I want to, let's get some more space here, create this, I'll just do the bar. I got a boo-boo, what did I misspell? Oh, gotta write subplot, not subplot. Okay, and we'll run that again for the bar. Okay, and so in that first, you can see, so it's anticipating there's going to be 3 rows of 4 columns. So there's going to be 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 figure spaces here. And you'll notice this is just plotting the averages. But what we're going to try to do is put the text right up here at the top of the bar. And that is what this text command is meant to do. So if I were to copy that, paste, and run it in the command window and go back to the figure, you'll see those numbers show up here. All right, and I'm just using the default graph color of blue. Here in bar, right here, you can customize that color and do a comma, like an R if you want them red, or you can Google like bar specifications and you can actually make them have no fill, so they're blank in the inside, but the outside is a special color. You can get pretty tricky with those. Now what we're going to do is plot the standard deviation bars. So this is where it gets a little trickier. Now we're going to add another plot on top, so I'm going to do a hold. And so I'm going to put hold on. What we're going to do here is specify, because the standard deviation bars want you to tell it what the high end and the low error is going to be. So I'm going to do ERR high, that's the high error side. And we're going to call that performance SDs. And I'm going to create a new sort of a pseudo x-axis here. So x will be 1 to the length of performance bars, so the performance variables. Okay. Now ER is a variable that we're going to create, and that's actually going to be the error bar. So we'll type error bar, that's a MATLAB function. The y-axis for the error bar will be the x that we created, right, 2 lines up, or excuse me, 1 line up. The performance variables are what we want to attach these to, so performance bars. I'm going to not use a plus or minus because I have the text in the bar and it makes it harder to read. So right here is where you would have an error low. If it's a standard deviation, you could put error high if you wanted, but we're going to put 2 brackets like this to specify don't put anything there. And then I'm going to put error high. Don't need the single quotes. I'm going to close this out and suppress. Okay. I'm going to specify the color of the error bars using error.color. And MATLAB uses RGB kind of coordinations, so I'm going to specify 000 here to give me that color that corresponds with that. Now the line style, so the error line style is er.line style. I want to make this none because I don't want it to be too flashy. Okay, and if I were to run everything after that hold, and then go back to the figure, you'll see I've got error bars up here at the top. Now there's a couple things we don't like. First thing is we don't have the notice for if there is any large change. Those would show up in the middle here. They will eventually show up in the middle here. But also the top of the y-axis is right on that standard deviation bar. So I'm going to lengthen that limit and put some more white space in the figure here. So what we're going to do here is another hold. Hold on. And I'm going to create a y, because we're dealing with the y-axis. And we're going to, well, actually, no. What I'm creating now, scratch that. This is, I'm not extending the axis yet. Right now, what I want to do is put on the large effect note on there. So if there is a large effect. So what we're going to do here is create that sort of x-axis variable, but we're calling it y. So we're going to go with 1.5, because remember, we're comparing 1 to 2, so I want the notifier to be in the middle of 1 and 2. So I've got to put 1.5, and it's going to go to the length of performance variables, but we're going to subtract 0.5 from that, right? Because the way that it works out with the comparison being in between each session, so 1 versus 2 means that that notifier is going to go on 1.5, right? And so we just got to close that out and make sure we end that correctly. Then what we're going to do is I'm going to use a stem graph. Now you can do other kinds of graphs. This is going to be a stem, and it's going to be y as our x-axis, kind of notice. ES plot, this is where we bring that out. I'm going to make mine red diamonds. So in the single quote, I'm going to put diamond with R. I want them to be filled, so I'm going to specify filled. And I want them to not have a line style, so the stem is actually going to be removed. All right, so no line style here. Okay, so now if I were to run this after this hold, now for us, I don't think we had any significant or large effects, so nothing's going to happen, but it would have showed up right here in the middle of these. Okay, and we'll see that on another variable we'll do here in a second. Then what I want to do here is do a y label. We know that we're working with landing height, so this is going to be meters. We'll give this figure a title and call it the variable we're working with, so landing height. Okay, and then what we also want to do is put a limit on the axis. Because if well, let me just add these on here. Okay, so that standard deviation bar still goes up here to the top. All right, so what I'm going to do here is do a y limit, which is y lim. Okay, and then I'm going to go with 0 as my first limit. Actually, I'm going to put a bracket here. So 0 as the base limit, because landing height will go from 0 to large number. And then what I want this to be is pick a random value, but I'll say 1.5 times. And we're going to use the maximum, so like we've done here, we can just copy this where we made the effect size plot certain height. But we're going to increase it by 1.5 times that height. So we're going to take the maximum landing height average plus the maximum landing height standard deviation and multiply it by 1.5. Right, and then we'll close that. So now we should have a big increase in white space up here in that figure. See? Right there. So now the figure looks a little easier to read. A lot less white space in there. So I'll go ahead and minimize that figure there. All right, and so the second graph we're going to make for this one, we'll do a landing time, because I'm hoping if we look at landing time, we might see a large change. Now the good thing is, if I just put just a temporary section break, so I know I can literally copy all of this stuff that we have here from the reshape down to the end of the plot and paste it here. Okay, now I'm going to go ahead and get rid of the section here, and I'm going to change landing height to landing time. Okay, so I'm just going to go ahead and do this. And you'll notice MATLAB's kind of cool. It says press Shift plus Enter to rename 10 instances of landing height to landing height reshape. So if I hit Shift plus Enter, you'll notice all these other highlighted variable names will change. Right, and those will change for me. But now what I've got to make sure is I just fix all those times where there was landing height. So you see I've got a few of them here, a few of them here. Notice I can make that change, Shift, Enter. Oh, but I didn't do it for this one. So I'll have to manually put it in here. So let's do landing time. We'll go to time here. We'll do time here. Trials will stay the same. Down here, we'll change this to time. Here, we'll change this to time. Effect size plot, we'll leave that name the same. Here, we'll put that to time. This one already auto-updated to time. We'll leave this line as it is. Now what we're going to do here is remove the figure specifier because we don't want another figure to pop in. So we can go ahead and delete that. We want to plot this right on to the plot. So now this is going to be still 3 rows, 4 columns. The second figure, so you can see if I were to just run that subplot, it'll bring in a space for that second figure. Now what's tricky is MATLAB, I can change this to be 2:3. Let's say I want this figure to be big. So it'll be the third 3 rows, 4 columns, space 2 to 3. So if I were to put that in here, you'll see it'll change and it makes it bigger. Right? So I can get creative with how I do this. So for instance, if I've got 3 or 4 performance variables but only 3 strategy variables, I can make those 3 strategy variables fill like a space and a half each, right? Now I'm not going to do anything tricky here for that, so I'm just going to do the 2. Performance variables, I'm going to change this to landing time, because I remember I didn't above hit Shift Enter for that one change that I made. This one already changed for me. Okay. All these performance variables, things like that, do not need to change. None of that needs to change. The only thing that changes now is because we're dealing with time. So my Y label is going to be time, or actually I'll just call it seconds. And this variable will be changed to time. And then my Y limits I'll also change because I forgot to change it before. When I do the Shift Enter, I didn't do it for this landing height averages. So we'll make that here. Okay, so if I were to actually just run, I can close this figure, just run this section, it'll do the 2 graphs for me. See, and they're both in there. Both of them do not have a significant identifier. I really want to plot one that'll show you the significant identifier. So what I'm going to do is pause the video real quick, finish the script to run all of the figures that I'm going to use, and then I'll let you visualize that for you so you can see kind of the creativity and what it will look like. Okay, so I went ahead and created the figures for all these, and I did it kind of quickly, so there's a couple things missing on some I noticed, but it's okay. So you'll notice we've got landing time. Oops, messed that part up. That should be landing height. Landing height, reshape. Oh yeah. Okay. There's an error I'm going to fix here real quick because I started calling landing heights landing time. So let me. Right, so I fixed that little error where I don't know what I was doing, where I typed landing time instead of landing height where it belonged. We see we've got landing height and its plot, landing time, its plotting characteristics, loading time, attenuation time. So I've got a number of variables here. We run them the exact same way that we did the very first one and the second one, just changing the variable names where appropriate, like we did for that first one. So what I'm going to do is go ahead and run the section here. And here that graph pops up, full screen. You'll see all my variables. I've got my performance variables, or at least what I'm considering performance variables. And then I've got strategy variables going on down here. right? So you notice peak impact force, the average force over the landing, the average force in the loading phase and the attenuation phase, loading rate, attenuation rate, and then I've got body mass in here also. Now you'll notice here where the asterisk pops in, or excuse me, the diamond pops in, there's the diamond right there of how it pops in the middle. So the only thing that changed here to a large magnitude was body mass, but if you look at it, it wasn't really that large of a change in terms of practicality. Unfortunately, across these trials, we didn't see any change that was large, across these 3 sessions, so you could visualize those, but those would be located in their respective graphs where they belong. One thing we've added that may not be in what we discussed is this key right here to show what the red diamond stands for, a large or greater change with an effect size greater than or equal to 1.2. Let me show you how we put that in there. So if I go to the very bottom, at the end of my last graph, I've changed the stem. So if you look at over here in the previous example we did, all I did was call this stem. I didn't have x equals. Now for all of your graphs, you can call those x equals and just let them override like this with a capital X. But I've only done it here on the last one for whatever reason. So that one is called x. Then down here, I'm going to create a legend called legend 1 because I'm going to have another legend in there on the graphs, right? So, well, perhaps on some of the graphs. And so I'm going to call this legend 1, and it'll be the legend of that x. And I'm going to say it's the large or greater change with a certain font size and turn the box off. So normally it'll put a box around the legend. I don't like that, so I took that off. And then here I set that legend to its positions on my screen to be centered up at the top. Now these positions, I mean, you can try to enter those in on your own, but it's screen dependent. So that's going to be something you'll look at in terms of the dimensions of your screen and need to know that. Now what you could do is not organize this position. So I'll show you how I figured out this position so I can use it for every figure that I want, right? So if I took this off and did not, well, that won't work. I gotta highlight the whole thing. So if I add comments to here and run this section with this new legend popping in, that legend's going to pop up in a default spot, which will be on the graph. See, right? And I don't like that. I want to put it in a certain location. So I'm going to go to view the property editor of this graph. Okay, oh, put it on the wrong screen. Let me bring it back over. And I'm just going to go ahead now and grab that legend and move it where I want it. So you might want yours at the bottom, at the top, wherever. And I'll just move it, and then I'll close this legend editor, and it'll stay here. So you can put it down here at the bottom. I like to put mine right here at the top. Okay. Now MATLAB's kind of cool because this figure, you can go here, File, Generate Code, and it'll take a second here, but then it'll spit out in a new script window the code for how to create this figure. And so it has a bunch of stuff. We don't need a lot of this. All we need is the legend location because we told it how to graph, right? So I'm scrolling down. Here we go. Here's the bottom, and I just need it to set the legend position. And so based on where I located it here, those, lack of a better term, coordinate locations, it's not really kind of what it is, but that's what these numbers relate to. So I can literally just copy this set legend command, go back to my script and put it here. Okay, and just paste it right there. So I've already got mine in here. But now you'll know whatever the screen you're working on, that's where that'll go if you want that legend to appear in that location. So once you've pasted that set legend piece in there, you can go up here and just close this script out. Don't save. Okay, so that's how you get that graph set. We're going to task you with creating those graphs for your jumping plot. The only thing that you're going to want to make sure you do is in your new section for your jumping graphs is when you get to the new figure, so like in the top of this one, where we had, let's see if I can get up there, right here, H2, you'll end up changing this 2 to a 1, and this obviously will say jumping results. Everything else, you can literally copy and paste that first figure for the landing one and put it down there in jumping, and then just change the names to the jumping variables like we did before. Okay? All right, and then just the final thing we'll talk about here is I went ahead, paused the video, and wrote the script here for the jumping graphs. So I've got my takeoff momentum with its new figure title in the graph. Okay, I then do that again for RSI mod, jump height, all my jump variables. So if I were to run this section for the jumping graph only, here we get a much better picture of change over time. So I've got my performance variables, I got 4 of them. You can see here where RSI mod actually significantly, or large effect size, so it was a large decrease from session 1 to session 2. Not by way of a decrease in jump height, but it was an increase in jump time, so they got slower. Down here I have my strategy variables for jumping in terms of time. You can see the phase times, so that jump time increased, you got slower because your yielding time, braking time, and concentric time all increased slightly. Then we can look at force production variables, how much body weight was unloaded. Second session we unloaded a lot less body weight. We generated a lot less amortization force, or force at zero velocity, and less force concentrically average. Now the rate of force development during unload, you unloaded much less, and you did so in not a different amount of time per se, so that rate of force development decreased. Here in the yielding, you can see the increase in yielding time, so that's going to change there. And then braking, if you look at the amortization force decreasing and the time increasing, well, that's going to affect that braking rate of force development. So here's a better depiction of how you can see where those changes in the sessions would occur. Now if we had changes in between every session, there'd be an asterisk, like for instance explosiveness, there'd be an asterisk between 1 and 2 and between 2 and 3. Okay, so that's just a better way that you can see those figures. Alright, so I'm going to close out that figure. Here's the landing figure that popped up also, and we'll continue with the third video, which will be about how we actually go about saving these. If you recall from early on, we specified whether or not we wanted to save. The next command will be to actually execute the save.